Okay, so we're gonna go over the Unit 3 polynomial review study again. Let's start with long division. So some quick notes on long division. We use the dad, mom, sister, and brother acronym, right? D stands for division. M stands for multiplication. S stands for subtraction. And B stands for bring down. Okay, so let's try to apply these to our first example. So first we're gonna set it up. We're gonna divide this by this. So this first one's gonna go inside our division. We have x to the third plus 6x squared plus 3x minus 20 being divided by x minus 1. So you could also do synthetic division if it's easier. I prefer synthetic division, but let's do one with the long way. So first, we gotta do division. So what that means is we're gonna get the first term of this expression. So x to the third, the whole thing. Let's do it over here. X to the third and divided by the leading term of this. So x to the third divided by x gives us x squared. So this x squared goes up here. Next, we're gonna multiply. So we're gonna multiply x squared with the x. We're gonna multiply the x squared with the negative one. So x squared times x gives us x to the third. X squared times negative 1 gives us negative x squared. Okay, from here, now we're gonna subtract. So when we subtract, the only thing that we gotta do when we subtract is we gotta flip the signs. So this turns into a negative, and this negative turns into a positive. And now we're gonna subtract, and these cancel out. Add everything down. 6x squared plus x squared gives us 7x squared. Next, we're done with subtraction, and we just bring down. Bring this down, we get plus 3x. Now we do the exact same thing. Now we're done with all of this, and we do the exact same thing and keep applying this over and over again. So division. We're gonna grab the whole first term. X squared plus 3x. Oh no. Just the first one. And the leading term over here, divide it. And we get 7x. We're gonna grab that 7x. We're gonna put it over here. Since it's not negative, we're gonna have positive 7x. All right, next, 7x times x gives us 7x squared. 7x times negative 1 gives us negative 7x. Okay, and we're done with multiplication. Now we're gonna do subtraction. So again, flip the signs and add straight down. These cancel out. These will always cancel out. And then we add these, we get 10x. And we bring down this negative 20. Okay, good. From here, we start again. Division. We grab the first term, 10x, and divide it by the first term here. Our first term is going to be x. So we have 10. And since it's positive, we put plus 10. If I had the negative up here, then we would put negative 10. But since here we have positive 10, we put plus 10. Now we do multiplication. 10 times x gives us 10x. 10 times negative 1 gives us negative 10. Okay, now we're going to subtract. So we're going to flip the signs from negative to positive. These cancel out. And I'm left with negative 10. Okay, so this is what we have, and then this is going to be our remainder. So what we're going to have is we're going to write x to the third plus 6x squared plus 3x minus 20. I'm just rewriting the problem. Divided by x minus 1 is equal to x squared plus 7x plus 10 minus plus minus 10 over x minus 1. Okay, so that's what we're going to have for that one. But let's say we wanted to use synthetic division. How would that look like? Let's see if we get the exact same thing. Okay. Do it on this paper. So we're going to do the exact same problem. X to the third plus 6x squared plus 3x minus 20 divided by x minus 1. Okay, so to do synthetic division, we first have to solve what we're dividing by. So we're going to set it equal to 0. We get x equals 1. And now we're going to rewrite this. Let's see. So we're going to have x to the third, x squared, x, and then our constant. So this minus 1, this x equals 1, we're going to write it right here. Just the 1. Whatever x is equal to, we're going to bring it, and we're going to put it right there. And here, we're going to write all of the coefficients for each of the x terms. So the coefficient of x to the third is 1. The coefficient of x squared is 6. The coefficient of x is 3. And our constant term is negative 20. Okay? So the way the log division works, synthetic division, is I just bring this down. I bring it down. Every single time, you just bring it down. Now, I'm going to multiply 1 times 1. So I'm going to multiply 1 times 1, and I get 1. 1 times 1 gives me 1, and I'm going to put it right here. And all we got to do is just add down. We don't have to do anything. We just add straight down. So 6 plus 1 gives us 7. Now, we're going to do 1 times 7. This gives us 7. So 1 times 7 gives us 7, and we're going to add it right here. 3 plus 7 gives us 10. And we do the exact same thing. 1 times 10. So 1 times 10 gives us 10. So we add 10 here. And then negative 20 plus 10 gives us negative 10. Okay, so here, since we started with x to the third, we're just going to decrease in power by 1. So here, I'm going to write x squared, and then x, and then c, And this is going to be my remainder. So this is going to be my answer, but we got to rewrite it a little bit to make it a little bit easier to read. So this is going to equal 1 x squared plus because this is a positive 7 plus 7x plus, and then 10, and then since it's a constant, we just leave it as 10, and then plus negative 10 over our x minus 1. Okay, and it looks like that's the exact same thing we got. So either way works. I like synthetic division, but you could also do long division. Okay, moving on to rational root theorem. So section 2. Here, to find all the possible roots, we just need to find two things. We need to identify the leading term, or the leading coefficient. So leading coefficient, and we're going to call this LC, and the last term. And we're going to call this LT. Okay, and all the possible roots. So possible roots will be given by the factors of LT over factors of LC. Okay? Okay, so here, example 3. What is the leading coefficient of this term, of this expression? The leading term, the leading coefficient will always be the number next to the highest power. Since it's in decreasing power, we just need to look at the first one. And it looks like we have an invisible 1. So our LC is equal to 1. And if we break this down, it's just 1 times 1. The last term here, or LT, is 20. And if we break this down, I get 120, and then actually, let's do it this way. I need a little bit more space. So 20, 120, 2, 10, and 3 doesn't go into 20, 4, 5, and then 5, 4, and then we'll go back up. So we have all of these. So we need a factor of LT. So we need one of these factors. So this is a factor. This is another factor. This is another factor, another factor, another factor, and another factor. And since here our LC is just 1 and 1, we just got to do 1. So then the possible roots, let me put this in different color. The possible roots will be 1, 2, 4, 5, 10, 20. Divided by 1, 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 divided by 1. And all of these are going to be plus or minus. So if I simplify this, 1 divided by 1, that's going to be plus or minus 1. Or 2 divided by 1 is plus or minus 2. 4 divided by 1 is plus or minus 4. 5 divided by 1 is plus or minus 5. And then plus or minus 10 and plus or minus 20. So these are all of our roots. Here, I'm not going to completely do number 4, but here, our LC, our leading coefficient is 2. 2. We're going to divide it by 1 and 2. And then our last term is 9. And we're going to break this up as 1 and 9. 2 doesn't go into it. 3 and 3. And I think that's about it. So we're going to have 4 of them. And we're going to divide it. The first, actually, I'll just do 4 completely. 1, 3, and then since they appear twice, we just need to write it once. 3, and then 9. Okay, so now we're gonna grab one of our LCs and divide it by 1. Divide it by 1, divide it by 1. And then these are all plus or minus. Okay, so here, we are not completely done yet. Since we have another term here, another factor of our LC, this 2. We also have to do another one. So we have 1, 3, 9, but this time we're going to divide it by 2, divided by 2, divided by 2. And these are going to be plus or minus. And then this one came from this one here. Yep. That's about it. Okay, moving on to multiplicity. So some quick notes on multiplicity. Multiplicity. Whenever you hear multiplicity, always think exponent. Right, and specifically multiplicity, this talks specifically about roots or zeros or x-intercepts. They all mean the same thing. We're talking about behavior at the points or where it crosses the x-axis here. So let's start with this one. Let's do, actually, yeah, let's start with this one. X plus 3. So x plus 3, 2x minus 1, and squared. Okay, so here, how do I find my zeros of this, my roots of this, or my x-intercepts from this? Since it's in factored form already, we don't need to do any factoring. We just have to set them equal to 0. So we have x plus 3 is equal to 0. And then here, we're going to have 2x minus 1 is equal to 0. Solving for x, we get x is equal to negative 3. And let's see, 2x is equal to 1. So then x equals 1 over 2. Okay. Now we're going to find this on our x-intercepts. X equals negative 3. We're going to have 0, negative 1, negative 2, negative 3. So we have a point there. Actually, let me put it in a different color. Okay. And x equals 1/2. This is 0. This is 1. So 1/2 is going to be somewhere right here. Okay. So going back to our notes, if I have an even multiplicity, we saw that this touches the graph, right? So it's gonna go something like this, and it doesn't cross it. If it's an odd multiplicity, it is crossing the, or touches the, I shouldn't say graph, touches the x-axis. So here it's gonna look like that, right? It's gonna cross it. So here what kind of multiplicity do we have? So here we have an even, and then here we also have an even. So here we're gonna come down, and then it's gonna do something like that, and then it's gonna go back up, and then it's gonna cross again. So we could do our graph something like this. It's gonna look something like this. Okay. Number 8 is very similar. However, we have a negative in front. So what that means is we're gonna sketch it. Then at the very end, we're gonna reflect it, right? Just how x squared has a graph looking like this, but negative x squared just flips it upside down. So first we're gonna graph it, and then we're gonna flip it. That's the only difference here. Okay. Okay, so here we started with a polynomial, and then we described its behavior and then graphed it. Here we're going to start with the behavior. We're going to start with the behavior, and we're going to construct a polynomial. So we want to go from our x-intercepts, and then we want to build it up to this, right? So let's do that. So x squared, we want to set it equal to 0. So if I want to set it equal to 0, I need to move this plus or this minus 4 over. So we're going to have x plus 4 is equal to 0, right? And then here we're going to have x plus 2 is equal to 0. And then x plus 1 is equal to 0. And x minus 3 is equal to 0. Okay, so we are here. So we started here, and then we're going up. Right? We started with the x equals, and then we set it equal to 0. And then what was our last step? We grab all of this. And you just shove it into parentheses. We're going to do the exact same thing here. We're going to grab this x plus 4, and we're going to put it in parentheses. X plus 4. We still don't know what exponents they're going to have, so we'll worry about that in a bit. So x plus 4. And then here, we're going to grab everything on the left and shove it into the parentheses. X plus 2. And then x plus 1. And then x minus 3. Okay, so we have our factors here, but we still got to figure out our exponents. What kind of exponents? Remember, we could have either an odd exponent or an even exponent. So remember, odd is numbers like 1, 3, 5, etc., and 2, 4, 6, 8, etc. So does not cross the x-axis at x equals -4 or x equals 3. So does not cross. So here, does not cross the x-axis. So here, this is an example of a behavior that does not cross it. This is a bounce, right? Or a touch. So here, we could rewrite this as touches at x equals -4 and x equals 3. So it touches. So if it touches at x -4, it means this is going to have a power of 2. It's going to have to be an even power. At x equals 3, it also means it's going to touch. So this is going to be a power of 2. And then for our notes for this section, we're going to put the degree is going to equal to the sum of all the multiplicities. So here, what is the multiplicity of this? 2. What is the multiplicity of this? This is an invisible 1, so we're gonna do +1. The multiplicity of this one, 1. And then the multiplicity of this one, 2. So if we add up the multiplicity, if we find the sum, if we add, sum means add or addition of all the multiplicities. So we have 2, 3, 4, 5, 6. This is what our degree 6 is. It means if I add up all of the degrees or all of our multiplicities, it should add up to our degree. Okay, so writing a polynomial. This is going to be it. This, and this. Okay, so then putting it all together, let's see, let me put it here. We're going to write it as f of x is equal to x plus 4 squared, x plus 2, and then you could add the 1 or you could leave it out. I would leave it out, x plus 1, and then last one, x minus 3 squared. Okay, so this is my polynomial. Good. Next is we gotta figure out what this is saying. This is the limit of f as x goes to infinity. So as x goes to positive infinity, as we go more and more this way, where is my graph going? It looks like it's going to positive infinity. So I'm gonna draw it something looking like this. It's gonna go to positive infinity. Okay, and now we're just gonna plot our points. X equals 3, 1, 2, 3. X equals -1, -1, -2, and -4. Okay. So we know at x equals 3, this one has multiplicity of 2. So meaning it's going to touch. Okay. Next one, this one has multiplicity of 1. So it's going to come and then it's going to cross it. Okay. And then x equals -2, also multiplicity of 1. So it's going to cross it. And then -4 is a touch. So it's gonna, it's gonna be, it's gonna be a touch or a bounce. So it's gonna look something like this. gonna look something like this. And very similar here, but here, I'll let you solve with these, but here we're gonna start at, as x goes to positive infinity, f of x goes to negative infinity. So meaning it's gonna go something like this. And then that's when you do your touch or bounce on your x-intercepts. Right? Okay, so one last thing. So here we talked about writing polynomials, so starting with the behavior and then writing the function. And then before that we did multiplicities. So this section, examples 5 and 6, are very similar. However, it's written a little bit different. We have x is equal to -2, 0, and 3. So this is kind of condensed. So what I like to do is just break it up into parts. So x is equal to -2, x is equal to 0, and x is equal to 3. And then from here, we can now solve. Yeah, right? Solve for 0, or set it equal to 0, so +2 is equal to 0. This one's already set to 0. And then this one is x minus 3. And then here is where we grab this and put into some parentheses, x plus 2. Here, x. And then here, x minus 3. And then you got to figure out the exponents for each one, right? And that's going to be based on this. Crossing at the x-axis only at 1. So meaning crossing, this is the only one that's going to be crossing. This is going to be 1, this is going to be 2, and 2. Okay, and double checking, degree 5. So 2 plus 1 plus 2, that's 5. So we're all good. So f of x is equal to x plus 2, x minus 3, squared. Okay. And then you just graph it. Okay, that's last thing.